Hello again and welcome. Today we're going to be looking at this NISSEI digital SWR power meter. This is brand new. You can see that this measures the forward and reverse power, the VSWR. Looks like it can be powered by two AAA batteries as well as a micro USB connector. This particular one is the RS-70, so it's rated for 1.6 to 60 megahertz and 200 watts. Now again, to be clear, I'm not a CB or ham radio operator. A while back I'd mentioned how the Bird 43 seems to be the industry standard for the CB and ham radio operators. They really treat that like a gold standard. And if you look at the manuals for those meters, they're rated for plus or minus 5% of full scale. And of course you have different slugs that you have to insert into those meters. So if you've got a 100 watt slug, for example, well, that's going to be plus or minus 5 watts of error. So if you have a 5 watt radio, you've already got plus or minus 5 watts of error on top of that. So you have to make sure when you use that watt meter that you're buying slugs where you're basically making use of the full range to get the best accuracy. Recently I came across a video by a gentleman who was a CB operator, I think. Anyway, he had done some kind of a watt meter shootout, and he had the Bird 43 along with this particular watt meter and another one. He had purchased a brand new Midland M30 CB radio, and I understand from that video that that CB is rated for 4 watts, and I guess it has a built-in watt meter. So he's using that as his reference. And he hooks up these other 3 watt meters, and long and behold, this Bird 43 he had reads identical to what the Midland radio said it's putting out, basically 4 watts. So he had one of these meters, and of course it read a little different, and his conclusion was that this meter isn't any good. So I was kind of curious. I tried to find a manual for this thing, and I looked all over the internet, and I could not find one. Oh, one of the things I should mention, when they shipped this box, it was shipped just like this. So this was not placed into another box. There wasn't even a piece of tape holding this down. So this was wide open. It could have flopped open during shipping, and it actually made it here. So I was quite surprised by that. Anyway, so if we look, it comes with this little pamphlet. So let's see, it can measure forward and reverse SWR ration in one push button. LED backlight for ease of reading. Power source, internal AAA batteries or an external USB port. I guess you could use rechargeable batteries in it. It does not come with a charger, or probably not the cable. This is the first time taking this thing out right here. Yeah, so no cable, just the unit. Again, it's rated for 1.6 to 60 megahertz and center calibrated 14 megahertz, I'm assuming, and 50 megahertz. Power range 200 watts. Insertion loss, wow, 0.3 dB or lower. It's probably lower. We'll measure that. It's made for a 50 ohm system, no surprise. Let's see, it looks like they can ship this with a Type N connector. Yeah, this has got your typical hammy connectors on here. We get down to the bottom, it says this unit has no built-in charging circuitry. Can use it with alkaline or rechargeable batteries. So way down at the bottom here we can see accuracy. So for over 5 watts it's plus or minus 5%, and then for 1 to 5 watts it says reference only. So we have no idea what the error would be below 5 watts, but above 5 watts is plus or minus 5%. I'm not sure if that's a full scale, or would that be of reading? I suspect that that would be of reading. So for 10 watts, for example, you'd have plus or minus 500 milliwatts of uncertainty. But that's the reason that I want to look at this meter, is I'm kind of curious how accurate really is this thing. Now again, I did a video where I made a homemade watt meter. This is it here. And this is one of the couplers for it. I don't remember what the directivity on these were, but it's somewhere above 30 dB. This particular watt meter I designed for 1 meg to 50 megahertz, and it's using a Analog Devices 808307. It has 2 of them that are located inside of this box, so those circuit boards are sitting here. Now again, I modified the input network for those 2 boards, and I also changed out the connectors, and this box just basically sits on the Ethernet port and ties to your PC. When I made the video for this, I'd mentioned that I still really have no idea how accurate this is. mainly because I don't know what the accuracy of the attenuators that I use have. But one of the things I had mentioned is that I have a Marconi RF generator, and I had compared the output of that with my signal hound, and when I look at that data, basically those two align right on top of one another. What I'd like to do today with this meter is just see if this thing is really as accurate as what the claims are. So I'd like to run this thing over the frequency as well as the power limits of it, and let's just see how it behaves. So the first thing I'd like to do is run a functional test on this meter. Let's just see if it does anything at all. So what I'm going to be doing is taking this little amplifier I've got, and we'll be driving this into this old Mars SWR meter I have. And I have a 50 ohm load that we'll be using. I'll put this in series with this meter. Again, I'm not trying to look at the accuracy. This will just basically be a quick checkout. So I've got the power amplifier on, and I've currently got it set to 14 megahertz, which is basically where they've calibrated this thing at. We'll check the VSWR of our load. Again, this is going to be basically perfect, but let's see. Yep, so you can see there's basically no reflected power. Normally I don't use these PL259s here in the lab, so what I've done is I've attached an N-style adapter to both sides of the meter. So on the output side here, you can see I have our 50 ohm load. You can see our amplifier isn't real happy right now. It's basically showing infinite VSWR. Of course, the output is not loaded. Let's go ahead and we'll just attach this to the power meter, and I expect that meter to drop, which it does. So it doesn't look like our power meter is causing any kind of excessive reflection. Alright, so let's go ahead and we'll power this thing up real quick. And there you have it. So it's currently showing a forward power of 1.4 or so watts. And the reflected power is 0. SWR is 1.0 to 1. So I think the first thing I'd like to know is if I reverse the two ports on this, what's that do on the display? So let's see, just even detaching the load, you can see our forward power now is 2 watts, and the reflected power is 2.4 watts. SWR is basically 100 to 1. So you can see now the reflected power is basically 2 watts and the forward power is 0. We'd expect that basically. There's nothing coming in this direction. So it looks like there's a discrepancy between the reflected and the forward power. But again, we're running it below the 5 watt minimum that it requires. So yeah, it looks like there's a fair bit of discrepancy between the forward and reverse on it. Alright, the next thing I'd like to do is just go ahead and insert a set of batteries. This is looking at the back label, and again we can see 200 watts plus or minus 5%. I had seen photos of this, and that's why I was curious, is that 5% of full scale or is it of reading? The case on this seems quite rugged. Oh yeah. And sure enough, it looks like it takes 2 AAAs. I'll just be using a couple of rechargeable batteries in it. Oh, you can see it doesn't like the rechargeables. That's too bad. I'd expect any new products that handle these newer style batteries. I went through my stash, and unfortunately I don't have any AAA batteries that aren't rechargeable, and because of the lower voltage of those, I'm not going to be able to use those with this meter. So I'm kind of stuck using a external battery for now. Should be fine. So what I'm going to do next is we'll connect the watt meter back up to our source. And again, right now I don't have a load attached, so we can see the forward power is reading 2 watts and the reflected power is 2.33 or so watts. So what I have here is some of the loads that I made up when I built that other watt meter. So these are all mismatch loads. So this particular one is a 100 ohm. This should give us a SWR of 2 to 1. So let's just go ahead and connect this thing up and see what we get. Huh. So we can see on our SWR meter how it's jumped from 1 to 1 to a little over 2 to 1. But notice our watt meter here does not reflect that. It's still showing a perfect SWR. Again, let's just detach this load. See, the SWR has gone to infinity. And here we are with our 50 ohm load, and again, you see it goes down to nothing. So I'm quite surprised that this thing isn't reflecting that. So this is 150 ohm. So this should give us a 3-to-1 SWR. And check this out, it's reading 1.5 to 1. Of course, our meter here is showing about 5 to 1. Let's just see if we retune it though. You can see it's reading about 2.5 to 1. Huh. Now this thing's off by quite a bit, I'm surprised. Here's a 200 ohm resistor. So this should give us a SWR 4 to 1. Again, if we go ahead and cal our old-timey meter, you can see it's reading just under 4 to 1. Huh. Let's try going the other way with it. Again, this is a 25 ohm resistor, so this should give us a 2 to 1 VSWR. And you can see it's reading roughly 1.4 or so. Yeah, I don't know, maybe it's more accurate with the lower load. I would have expected with this 100 ohm resistor, again 2 to 1, it would read roughly the same. But you can see it reads 1.0, but notice our old-timey SWR meter, again it's reading roughly 2 to 1, a little bit off. But this thing reads basically flat. I think it's because we're running at such low powers. Unfortunately, with these loads here, I think these are a 2-watt resistor, so I probably can't crank this thing up a whole lot higher. Let's just give it a try. Again, this is putting out about 8 watts now, according to the meter, and you can see the SWR is still reading 1.0, and that's with our 100 ohm resistor here. Again, let's try that with our lower value. Hey. We're really pushing that poor resistor. Again, let's try that with our 25 ohm resistor. Again, it should be 2 to 1 SWR. And I'll go ahead and crank up the power a little bit. And you can see now that I'm up to about 10 watts, 2 to 1. Of course, that resistor is not going to like that. Let's try adjusting it down a little bit. So there's 7.3 watts, and it's still reading 2 to 1. Let's go a little lower. Here's about 5.5 watts. Looks like it's still reading right. Let's go a little lower. 3 watts, about 1.8 to 1. So this is a 10 ohm resistor. Again, that should give us a SWR of about 5 to 1. And let's see what we get. It's odd. So looks like the forward power is 3 watts and 6 watts reflected power. Again, let's try taking the power up a little bit and see if that corrects. I mean, there's 10 watts right there, and you can see it's got 13 watts reflected power showing. It's like there's a limited range that we can work within. And again, this is a 150 ohm, giving us a SWR of 3 to 1. And let's try turning up the power a bit. So there's about 10.8 watts, and you can see it's reading 2 to 1. It's not very accurate. It's interesting too, I don't understand why the backlight flashes. You can see I've got the switch set to off. Every now and then it turns it on. I don't know if that's a firmware problem or maybe the fact that I'm running it off of a battery. I'm not sure what's going on there. And you can see the battery's up at full charge. Yeah, I'm not sure. Again, for these mismatch loads, I'm using an old-time carbon comp resistor like this one shown here. You can't use a wire wound resistor for this. So if you're curious if this is actually a 100 ohm resistor, see I have my little Bryman meter out. And I've just got some adapters here. Let's go ahead and insert this. Again, it's a little warm right now. And you can see it reads 99.26 ohms. So very close to 100 ohms. So again, for these very low frequencies, I'd expect this to show us a SWR 2-to-1, especially once we get over 5 watts. But again, when I flipped the input and the output, there was a pretty big discrepancy between the two. So there's obviously something going on with the meter. Maybe it's just not that accurate for looking at SWR. So to look at the insertion loss, I'm going to be using our 3589A. Again, this network analyzer is good for 10 Hertz to 150 megahertz, easily covering the range that this is good for. Now again, insertion loss is basically if I have a perfect through and I calibrate to that, what kind of loss do we see when we insert this? That's what the insertion loss is. So again, what I have here is our two N to PL connectors, and then I have an SMA adapter on each of the ends. These cables go back to our network analyzer, and then here I just have a PL through. So what I'm going to do is take out our through, and we'll go ahead and insert our watt meter. You can see there is a little bit of loss here. It's 60 megahertz. It's 0.07 dB down, but again, they specify the insertion loss for 0.3 dB or lower, so 0.08 dB. It's well within specifications. So for that parameter, it looks okay. One of the things I forgot to mention is when I looked at the directions for this watt meter, again, it states below 5 watts. It's for reference only. So this meter isn't designed to be accurate below 5 watts. Now again, that video that I was referring to, where he had used that Midland M30CB radio as a reference, again stating that that was a 4 watt output, this meter is not going to be designed to make that measurement. So for me, it was kind of pointless that he would even show this meter. Now again, what I'd like to do is run this thing at higher power levels, and unfortunately this little amplifier isn't going to cut it. You can see we get about maybe 10 watts out of it is all, and this load is certainly not large enough to be able to do those measurements. Again, this watt meter is rated for 200 watts CW. Off to the right I have my 10 dB attenuator. This particular one is made by Bird and it's rated for 300 watts. Below that I have my JFW. Again, this has a Berry Industries attenuator in it. This is a 20 dB attenuator and it's rated for 100 watts. Again, there's fans mounted to the back side of this, and I can pull a little bit more than 100 watts. And then off to the left, this is a Mini Circuits 10 dB attenuator. So overall, we have a 40 dB attenuator here. And when I made the video showing my homemade watt meter, one of the things I mentioned is that I really don't know what the value of these attenuators are. Again, with this watt meter only being rated for 60 megahertz max, these are going to be very flat. So what I did is I hooked this whole setup up to the network analyzer, and then I swept it between 1 and 60 megahertz, and then I measured the actual attenuation. So to make these measurements, I've got a Rody Schwartz watt meter, and that's connected up to this small tablet. So the meter on the left, this is reading out in watts, and again, this is after compensating for the errors of our 40 dB attenuator. And then I'm calculating plus or minus 5% of that reading. So the upper display is the maximum and the lower is the minimum. Now we're going to be starting at 14 megahertz. And again, I'm deriving that frequency off of a Marconi RF generator, and that's tied to my GPS reference standard. Unfortunately, there's no way to log the data off of this watt meter to a PC. So we're going to have to run this test kind of manually. So what I'm going to do is just go ahead and increase the power here. So you can see we're putting out about 560 milliwatts, and our watt meter is displaying 450 milliwatts. Let's go ahead and we'll take it up a little higher. So here's roughly 5.01 watts, and we can see our watt meter is displaying about 3.98. So about a watt of error. Again, this falls outside of the 5% of reading. So let's go ahead and we'll take it up a little higher. So this would be 10.5, and the maximum this meter should read is about 11.05 down to 10.0, and you can see it's reading 10.2. So at 10 watts it's within 5%. So this is roughly 51 watts, and you can see our watt meter is reading 52.17. again within 5% of reading. And here we're at 102 watts, and you can see our watt meter is reading 109. The upper limit would be 107, so it's outside of the bounds of 5%. And here we are at 152 watts, and you can see our watt meter is displaying 162. I don't know what it did just there. It looks like it almost went through a reset. Everything is definitely tight. So again, it's about 10 watts high, which would be outside of the 5%. Let's take it on up to 200 watts. Okay, so you can see right here at 198, as I continue to go up higher, this thing is going to roll over. So at 200 watts, it actually reads 100 watts. So here we are at 199 watts. And then this meter would be reading about 204 watts or so, which again would be inside of the 5%. So at 14 megahertz, it appears to be close to about 5% of error. Let's change our carrier frequency to 7 megahertz, and we'll try running a similar sweep, and let's see what happens. So at 2.5 watts, you can see our watt meter is reading 2.01. At 10.3 watts, you can see it's now reading 15 watts, well outside of the 5%. Let's just go ahead and continue on up. Well, that's a major amount of error. So at 50 watts, you can see our watt meter is displaying 85. And here we're at 102 watts, and you can see the watt meter is displaying 180. That's really bad. I don't know why this thing is off so far. So I've set our carrier frequency now to 3 megahertz. Let's see how it behaves down here. So again, this is about 1.5 watts. You can see the two meters are basically reading the same thing, 1.53, 153. Let's go up a little bit higher. Here we are at 3.9 or so, and you can see the watt meter is displaying almost 7 watts. Here we're close to 10 watts, while on our watt meter is displaying 20. Looks like it's getting worse as we reduce the frequency. You can see we're putting out about 84 watts, and our watt meter is displaying about 180. And you can see what happens here. 90 watts, it's rolled over already, it's displaying 113. I wonder how high it goes up. Looks like that's where it saturates, so this would probably be 256.9 watts is where it stops. I mean, I can add more, and you can see the display doesn't change. So again, it's definitely been calibrated at this 14 megahertz. Let's try it at 50. Maybe it'll do better up there. Alright, so I've changed our carrier frequency to 50 megahertz. We'll go ahead and start increasing the power. So here's 1.3 watts, and you can see it's displaying 1.63. We're putting out roughly 5.13 watts, and we can see the watt meter is displaying about 5.5 watts, so close to 5%. Let's go ahead and increase it a little higher. We'll take it up to about 10 watts. So here we are at 10.3 or so watts, and our watt meter is displaying 11.7. Again, outside of the 5%. And here we are at 25.7 watts or so, and you can see it's displaying roughly 30 watts. Alright, we're putting out about 100.6 watts now, and you can see the watt meter is displaying 127.7. And here we are at 162 watts, and you can see our watt meter is displaying 196. Now again, this thing is rated for 200 watts. What I'm going to do is take the actual power up to 200 watts, and we'll just let this thing soak. Alright, so here you can see we're putting out about 200 watts right now. Our watt meter is displaying probably 232 watts or so. Again, well outside of the 5%. Looks like it's got a sweet spot at about 14 megahertz. What I'll do is I'll just let this thing sit for a few minutes and heat up, and we'll see if it causes any damage to the watt meter. Alright, it's been running for a few minutes now. Meter's not hot at all, maybe a little bit warmer, but it looks like it survives this test just fine. Alright, I think that's going to be it for this video. I'm totally unimpressed with this device. First thing that I noticed is this backlight. So you can see right now it's set to on. I'm expecting that backlight is going to be on 100% of the time, but it looks like it's trying to maybe save the battery where it shuts the backlight off after a certain amount of time. It's not what I would expect. The other thing I noticed that when I have it off, it'll turn on the backlight as the power starts to change, and then it shuts it back off. So I'm not really sure what this light switch does. It does turn it on instantaneously, but it times out, and if you have it off and the power's changing, it turns it back on anyway. A bigger problem I see with this is supposed to measure SWR, and again, when I hook this thing up to a low power source, what were we running, maybe 10 watts, and I flipped the polarity of this, you saw that the power didn't track. And when we started hooking up our load resistors, and I tried a 25 ohm and 100 ohm resistor, the 25 ohm measured alright, I guess, but that 100 ohm resistor measuring, you know, flat SWR, there's no way that's right. Both of those should have read roughly 2 to 1. I mean, I've got this old Mars meter again. This thing was probably made in the 50s, maybe the 60s. This was more accurate than this for measuring SWR. To me, if you're going to spend $100 on a digital meter like this, I would have expected this to far outperform this. And of course, another thing that this is supposed to do is measure watts. At 14 megahertz, it's close to 5%, but anything outside of that band, the error on this just goes through the roof. It's basically not usable as a watt meter or an SWR meter as far as I'm concerned. I'm not even sure why you would spend the money on it. Now maybe this one's defective. I don't know. I bought it brand new. I had just opened up the box to perform these tests, so this is the first time that I'm running it. So if you've purchased one of these and you've actually compared this with some known standards, I'd be interested in hearing what you have to say about it. Maybe yours works better than mine. Again, this Rohde-Schwarz watt meter that I've got, being a thermal type, that particular watt meter is not under current calibration. In other words, it hasn't been compared to a NIST reference standard. Now what I did do is I took it into work and I compared it against some of our equipment, and that thing is deadly accurate. I was very surprised how well that thing performs still. So I have no doubt that that meter reads correctly. Again, I have a BB60C signal hound, and I've compared that to my Marconi RF generator, and those two match. So another thing I had done is I compared that Rohde-Schwarz watt meter against the Marconi generator, and again, those two match. So it appears to me that all the error that we're seeing is attributed to this poor watt meter. The other thing with this is it can't measure peak power, it's CW only. Again, the signals that I'm injecting here are just nothing more than a sine wave, so we're not doing any type of modulation. If it did have other features like percent modulation or peak, I would have tried running additional tests like I did with my homemade watt meter. Well, I think that's going to be it for now. I consider this video basically a total flop. Hope you enjoyed it. Maybe we'll see you in the next video. Till then, later.